Lesson 26, parallel circuits. Okay, we will learn how to interpret parallel circuit diagrams. So this is an extension of what we did last time, which is when we looked at series circuits. Now we're going to start tackling parallel circuits. We're going to talk about today's lesson fact is Nikola Tesla, and he was is one of the most famous engineers and physicists in the world. He actually is one of the. He actually didn't get a Nobel Prize or anything, but he's still he's still a well-known inventor. Is in a common misconception that Thomas Edison stole Nikola Tesla's invention. Oh, okay. Nikola was hired by Edison himself, meaning anything that he made or invented by Tesla would be property of Edison. And that's actually how intellectual property works. If you're working at if you're working at like Melbourne University and you invent something, then Melbourne University technically owns your invention because, well, you use their knowledge and their experience and their whatever they had, maybe their equipment to make that invention. So they technically have a part of it. The main reason it was thought that Thomas Edison stole Nikola's invention is due to the fact that there was a supposed wager made between the two men, with Tesla stating that he could improve the company's current generators. Tesla eventually was able to redesign the generators and should have technically won the bet. However, Edison stated he was only joking and the bet was a joke. For his efforts, Edison expressed that he would raise Tesla's wage by $10. Outraged by this result, Tesla quit, and I believe that Edison was wrong by joking about the wage and what Tesla should have been given is his promised award, despite already working for Edison. So it's sort of this idea of like, is it stealing if it's the company? And it's like, well, that's essentially how Edison actually managed to invent so many different things. Is he just managed to acquire people that were very, very smart. Quick heads up for the person that wrote this, so I've already forgotten. I noticed whenever you refer to someone in a news article like this, you should try and use their surname instead of their first name. So instead of Nikola, you should use the word Tesla, just because it's just like a common phrase. Anyway, let's jump back to last lesson. For those of you that weren't here, this should be the first time you've seen it, but let's have a look at what we did last lesson. Last lesson, what we did was we looked at, we talked about these in a bit more detail. We actually spent the first part of the lesson talking about how the total current in a series circuit is the same no matter where you go in the circuit. We talked about the total resistance is the sum of all these smaller resistances. We talked about how the total voltage is the sum of the voltages, or the voltage drop over each individual resistor has to add to the total. In a parallel circuit, it's a bit different. In a parallel circuit, each branch adds the total current. So if you've got one branch that's got 1.1 amps, you've got another branch that's got 3.2 amps. Together, they're going to make 4.3 amps. So they add together. The current, the resistance is actually worked out using this formula. We'll talk about that in a bit more detail later. And we said that each path must have a voltage drop. So essentially, this one's almost the same as saying V total equals V1 equals V2. Sort of similar. It's like this one and this one, they swap around. We did some examples where we looked at 8 resistors measuring 2 ohms. And then what we did was we looked at it. We didn't actually do the challenge. We skipped the challenge. But we looked at 2 examples. Our first example was this guy here. And our first example explored this circuit where you've got 2 light bulbs of the same. And then our second example that we did is one that involved a 1 ohm and a 4 ohm, so different resistances. And we noticed that because there were different resistance, this one had a higher voltage. Now we're not actually going to do these again because I've already done them. What we're going to do now is we're going to move on to a new idea, which is not a new idea, but the same sort of idea. And hopefully that those of you guys missed the lesson can pick up on the way that we do things. And those of you that can't, this is new, then I want you guys to see. I'm going to get your input as well. I'd like you to copy this circuit down here. This is still a series circuit. Actually, I'd like you in chat to tell me, how can you tell, or you can say out loud, how can you tell that this is a series circuit? What clue is there there's a series? They're in a row? Yeah, perfect. It goes one then the next. So we've got a series circuit here. We've got a value. We've got some other information as well. But I want you to jot this down first. I'm going to give you guys another maybe 20 seconds to copy this down. Then we're going to start tackling this question. If you're reaching for a ruler, don't worry. It doesn't have to be too precise. Okay, so how do we do a question like this? If you weren't here yesterday, if you weren't here on Thursday last week, you probably don't know how to do this. But what we do is we start off, we're going to look at the three main points here. I'm going to start off with voltage. I always like starting with voltage. And I always do voltage in blue, but it doesn't matter. What we do, actually, the first place we need to start, before we even do that, is we need to label these. We're going to call this A and B. You could have A, B, C, D, E, F, whatever. You could call it 1 and 2. It doesn't matter. But what we're going to look at now is we're going to look at the voltage. We're going to look at the voltage at A, the voltage at B, and the total voltage. Actually, you know what? I'm going to do these. I'm going to do all my working out on the left side here. We've got a little bit more space. The voltage at A, the voltage at B, and the total voltage. Now, I don't know what the voltage drop at A is. I don't know how many volts is going to get dropped over A. The main reason is because it doesn't say. I just have no idea. I don't know what the voltage gets dropped over B. I have no idea. But I do know what the total voltage is. That's 4 volts. So I'm actually going to write that down. 4. And that's all that I can do with voltage. The next one after voltage, I guess, would be current. Now, we're going to look at the current through A, the current through B, and the total current. Do we know any of these facts? Do we know? I'm going to ask this to chat. I would love you guys to input an answer here. Do we know any of the currents, like any of the total currents or the individual currents? Do we know any current? Oliver says yes. Well, what do we know? What do we know? Can be a bit more descriptive. The ending of the circuit. So which one would that be? A, IB, or IT? Is that going to be the current through A, B, or T? Someone says A. Has anyone got any other answers? Is this the current through A, B, or the total current? Okay, 2 people saying, 1 person saying total, 2 people saying A. Ladies and gents, it is actually the current for all 3 of these answers. Because remember, the current, there is only one path for the electrons to go through. So if the current's 0.4 here, then it's going to be 0.4 here. It's going to be 0.4 here. the current is the same all the way around the circuit. Now what that does is that leaves us with the resistance. Now the resistance, do we know any of the resistance? Do we know RA, RB, or RT? Do we know any of these guys? And if we do, can you tell me what information we do know? We know, what do we know? Yeah, we know that the resistance of B is 4. B is 4, yep. So we know this is 4 ohms, but that's all we do know. We know this RA is X, but we don't really know what it is. And ladies and gents, what we've done now, if you're unaware, is we've actually extracted all of the information into this little table here. Mind you, we've got this little table that's a bit squashed, but that's okay. Now, what do we do now that we have this table? What we do when we have this table is we do something that I like to call tic-tac-toe. Tic-tac-toe is noughts and crosses, for those of you who don't know, which is when you have so on. So what we're going to do and how we play tic-tac-toe is we're going to look for lines that have 3 across or 3 down that we can fill in. Now, actually, ladies and gents, from looking at this, there's only one way that we could play tic-tac-toe and complete a set of 3. I'm going to leave it up to you guys. I want you to look at this question for a second. I want you to have a think. So look at these. Imagine this is like tic-tac-toe. Is there any way that I could put in one number to complete either a row or a column? Have a think. And then I want you to put an answer in chat. I've already got one answer in chat. But have a think first. Have a quick think before. Oliver, I know that you might have an answer, but I want everyone to have a quick think. Okay, go. I want you guys to write in chat what we could calculate. What could we find to make a row of 3? What do we need to find out? Or what can we work with? Now, Leo, you've suggested R total. The R total doesn't work because if you look at R total, we've got a missing square and a missing square. So that's not going to work. VB is what Elaine suggested. And Eric also says, and if you have a look, yes, VB is going to be the correct answer because we've got 1, 2, 3. We've got a full line. So we can calculate VB. Let's do that. VB is going to equal IB times RB because remember V equals IR. Now I know what IB is. IB is 0.4 because it's the same current for the whole thing. And I know that RB is 4. So 4 times 0.4, that's going to be 3.2 volts. So that is our measure, 3.2 volts. Perfect. All right. So that's how we play tic-tac-toe using this thing. Now, next thing, can you guys tell me what is the next thing we could play? What's the next row or column that we could get a tic-tac-toe in? What's the next row or column that we could get all 3 things in? And then Oliver straight off the bat says VA, and Oliver, you are correct. VA, because if you have a look, VA straight up there, we've got a full line. If you think about that, that would be the equivalent of having an X and X. We just need one more X to get a win. That's what I'm trying to say here. So let's think. But this one we can't use V equals IR. So we're going to use a different approach. For the approach to this one, we're going to use this. We're going to say, well, the total voltage, I'm actually going to do this in blue. The total voltage is going to be the voltage of A plus the voltage of B. What does this mean? That means that if you knew how many volts gets dropped here and how many volts gets dropped here, if you add those together, they have to equal the amount of volts coming in at the start. Because you can't drop more voltage than you have. So let's just see. VT, we know that's 4. VA, we don't know what VA is. But VB, we know. VB is 3.2. That means that VA is going to be 4 minus someone's corrected me. Someone is right. This is 3.2. 4 times 4 is 16. That should be 1.6. Oh man, that's embarrassing. Mr. Greer makes a big boo-boo. 1.6. Jeez.
I was wondering what you put there.
So that means that this should actually be minus 1.6. So that means we're actually going to have VA is 4 plus 1.6. Whoops, no, sorry. I was right the first time. 4 minus 1.6. We'll get there in the end. 4 minus 1.6, which is going to be 3.4 volts. No, 2.4 volts. Let's do this again because I made a lot of mistakes in this past little bit here. I apologize for that. But the first mistake that I made was right here. First things first, 4 times 0.4 times 0.4 is actually 1.6 volts. Now 1.6 volts is going to be VB. So if you add them together, then you're going to get 4. So if I take 4 and I subtract 1.6, then that's going to give me what the other answer is, which happens to be 2.4. So that's how we get 2.4 volts. Can someone got a suggestion for me for now what I would have to do to get, what's the next tic-tac-toe that we could get? Actually, by the way, I lied. There was more than one tic-tac-toe that we could have just done before, just done then, but that's fine. What's the next tic-tac-toe that we're going to make? R total. Sure, let's do R total. Why not? So R total, how do we do R total? R total, well, we're going to use this. V total equals I total times R total. That's going to mean that V total divided by I total is going to give you R total. Which is going to be V, which is 4 divided by 0.4, is going to give you a total resistance. 4 divided by 0.4, I think that's 10. But I might be wrong. So let me just double check. It is 10. I have a tendency to get this wrong sometimes. And given I made so many mistakes, I'm actually going to double check. It is 10. Beautiful. Equals 10 ohms. So that's 10 ohms here. So the last question is that what is the last thing we need to figure out? What is the last tic-tac-toe that we need to work out? RA. Now the interesting thing about RA is that there is 2 ways we can get it. The reason there's 2 ways you can get it is because If you do RA, there are two ways we can get this tic-tac-toe. So if we were to use the across line, what we would do is we'd say V equals IR. So VA equals IA times RA. So therefore RA equals VA divided by IA, which equals the voltage through A is 2.4. The resistance through A is 0.4. 2.4 divided by 0.4 is going to give you, I believe, 6. 6 ohms. Now, because there's two ways to solve this, you could also go up. There is another way you could do that, and that's actually using this formula here. You could instead say RT equals RA plus RB. Now, because you know that RT is 10, RA is X or whatever, and then you've got RB is 4, you can work out that X has to equal 6. So that's how you get 6 ohms there. Beautiful. And that's how we can calculate this. What I'd like you guys to do now is, could I get you guys to copy this down here? I'll be with you guys in a sec, but I'm going to give you guys to copy this down. Sorry guys, I'm back. Hopefully you guys will give you plenty of time to copy that down. Someone just joined. I'm not sure who that was. I just clicked yes. So we're gonna now move away from series circuits. So this is the one we just finished. And we just finished this one. So I'm just gonna recap one thing about this before. So someone had to speak to me. So we know this is 66 ohms now. We know that this has got a larger resistance. And because it's a larger resistance, you see that the larger resistance leads to a larger voltage drop, whereas the smaller resistors leads to a smaller voltage drop. And then we can use these things. The other thing I wanted to really go through with you guys to make clear is that, like, ultimately what we're doing is we're playing tic-tac-toe. We're going across and we're going down and stuff like that. One thing I want to point out with you guys is as well, because I don't know, sometimes I don't really see this very often. Usually whenever I give students questions, I'll usually only give them like two or three, two different light bulbs or resistors. But that's not to say that these can't be done with three. If you have, instead of two, you have VA, VB, VC, and then V total. You still play the same game. You still play like tic-tac-toe and you go across and down. It's just you have an extra row. That's fine. It actually doesn't make it any harder. It doesn't actually make it a little bit harder, but it doesn't make it like any more complicated. So what we're going to do now, though, is we're going to talk about parallel circuits. Now, parallel circuits are a little bit different. You need to use a couple of extra tricks. The extra tricks to remember with parallel circuits, let's go back here, is to remember that you've got the current in each branch adds the total. So be careful. We're not like looking at, we also need to also know that, the total resistance is linked instead using this formula. But this is perhaps the easy way that we can actually solve a lot of our problems. I actually very rarely use this formula. I only use this formula if I really have to. And that's because the advantage with these types of questions is there's always more than one way to solve them. So let's give this a crack. You guys should have had plenty of time to copy this down now. Let's play around with it. I'm going to call this one at the top A. I'm going to call this one at the bottom B. Bottom B, that makes sense. The top marks gives you A, beautiful. So how do we approach this guy? So let's write down our information. We've got VA, VB. All right, so let me write this all the way over on the left, so I've got have plenty of room at the end. We've got VA, VB, VT. Now we know our total voltage. It says it right there. It's 6 volts. Here's my question for you guys. Do we know the voltage through A and B? Someone say something here. Yes, we do. And Elaine, you are correct. Sorry, I know I'm picking on you. If you don't want me to say your name, I can just keep you anonymous and say anonymous person said yes. But yeah, do we know what is that voltage? We know what the voltage through A and B is. What is the voltage through A? 6 volts. That is 100% right. We know that the voltage through A is 6 volts. And this is why sometimes in some ways that these circuits are quite easy to do. We know that this has to be 6 volts because it has to drop all of its voltage before it gets back to the start. So if we know that's 6 volts, we know that VB is also 6 volts. These don't add up. Unlike in a parallel circuit where these add up, these are all the same. It's almost like with a series circuit, the current and the voltage swap roles. Because what we're going to do now is I'm going to write down IA. I'm going to write down IB, and we're going to write down IT. Now I'm going to ask you guys straight up, do we know any of these values straight away without having to do any calculations? Do we know any of these values straight away? No, we don't. Nothing is written down here. We don't know IA, IB, or IT. We have to work these guys out. So we're going to leave them. I'm going to leave them for a little bit. We're going to come back to them. What we're going to do now is we're going to do R. Do we know RA, RB, or RT? Do we know any of these values? In chat, we have an answer here given to us as, we know A and B because A and B are 3, and that's exactly what it says. A is 3 ohms. 3 ohms is written there. 3 ohms is written here. Do we know RT? We don't actually know RT. And some of you guys might be saying, isn't RT 6 ohms? RT is not 6 ohms. RT is not 6 ohms because in order to get RT, you would have to add them. And you'd have to add them like this. So now the next question's here. This is actually a bit of an interesting question. We actually have now extracted all the information out of this picture. The next question is going to be, we now need to fill in all of these extra parts. So can you guys suggest to me, if we were playing tic-tac-toe, what would be a line that we could fill? Is there a line that we could fill? Is there a particular value that we can now calculate or find out using our tic-tac-toe method? Say it in chat so I know which one we want to do. So what do you guys think? IA, perfect. And that's actually where I would start. You can actually find there are 3 tic-tac-toe, there are 2 tic-tac-toes here. No, 3. There are 3. There are 3 things you could do: IA, IB, or RT. Now, I would not do RT. RT is going to be difficult to do. You can do it if you want, but I'm going to avoid doing RT. We're going to do IA first. Now, IA is we're going to do that, we're going to use this. VA equals IA times RA. We want to know IA, so we're going to divide both sides by RA. IA equals VA divided by RA. That's going to be 6 divided by 3. It's going to be 2 amps. Okay. Now I'm going to skip. I'm not going to ask you guys to do this one because guess what? It's exactly the same. VB equals IB times RB. VB is going to be, so therefore IB is going to be VB divided by RB equals V is in this case 6 over 3. 6 divided by 3 equals 2 amps. Exactly the same method. Now, what's going to be our next thing that we're going to calculate? Can I get a suggestion from you guys? What would you guys like to calculate next? Or what's a good thing to work on to finish up everything? We've got 2 missing spots. What would you guys like to calculate next? I really hope you say the one that I want you to say. I total. Yes, that's what I would calculate next. I total. Now, I total is a bit interesting. I total, let's do I total. I'm going to do that I total in dark green. I total, if we know this is 2 amps here, and we know this is 2 amps here, I total is going to be what comes out afterwards. So that means I total is going to be the addition of both of those 2 smaller currents. IT is going to be I1 plus IA plus IB. Be careful, guys. This will not always be the case. But because we've got these 2 junctions coming together, we can easily work out I total. 2 plus 2 equals 4 amps. which leaves us with RT. And I saved RT for the end because RT is perhaps the most annoying. Now with RT, we could calculate that in two ways, here or here. I'm going to show you both of them. I'm going to show you the easy one first, which is kind of nice. The easy one, in my opinion, to do is like this. VT equals IT times RT. Now we know that RT is going to be VT divided by IT, dividing both sides by IT. VT is 6. IT is 4. 6 divided by 4 is the same as 3 over 2, which is 1.5 ohms. 1.5 ohms. Okay, now there is another way, and we could have actually done this at the very, very beginning, but there is another way to do it, and that's to go like this. I'm going to do this underneath it. RT, 1 on RT, and I don't like this way, I will point this out. 1 on RT, I avoid it if I can, equals 1 on RA plus 1 on RB. That's going to be the same as 1 on 3 plus 1 on 3, which is going to be 2 on 3. That means that RT is going to be the flipped over version of that. So equals 3 on 2, which is 1.5 ohms. That's just another way you could do it. And that is now that full circuit. Let's talk about for a second some bits and pieces. I would like to actually flag something with you guys. What I want to flag is notice how, firstly, the thing I want to flag with you guys is RT. It's the interesting part that I find about RT is that the current, the resistance of the total circuit is less than each individual resistor. You could actually get the same circuit if you actually had a circuit that looked like this. Which is kind of interesting, I think. Yeah, it's just something worth paying attention to. Right, we're now going to crank it up a notch. We're going to move from this parallel circuit to a very similar parallel circuit. The difference, of course, here is the resistances are different. I'm going to give you guys a little bit of time to copy this down, and then we're going to make a start. That actually gives me a chance to plug my laptop into a charger. All right, I'm plugged into a charger now. So we should be getting some power. Yes, all right, so let's do this next one. So this next one is parallel circuits, but we've got a bit of a different circuit here. We're going to do the same bits and pieces that we've been doing. And yeah, we're just going to solve this problem. Let's do this. We're going to call this top one A. We're going to call this top one, bottom one B. A reminder to you guys that it doesn't actually matter what you call these each individually. But yeah, we're just going to call them A and B. Done. Perfect. Let's get rolling. So we're going to start with, I'm going to do the same. It's almost like a matrix. You guys haven't studied matrices yet. That's probably, actually you guys might do that. If you're doing advanced maths, you might be doing matrices. But it's, yeah, we're essentially doing a matrix. We're going to work out, we're going to write down VA, VB, and VT. Now, if you don't like the word matrix, that's fine. It's just a grid. We're just going to make the same grid over and over again. Now, can you guys tell me one of those facts? Do we know VA, VB, and VT? Do we know any of those bits and pieces of data or not? VT is 10. That is correct. VT is 10. Do we know VB and VA? We've got someone saying no. The answer is, it is also 10. Because remember, these 10 volts have to get dropped over this path. The only place that they can get dropped over this path is at this resistor here. So that's why we say that that resistor is 10 volts. Same with this resistor here. It's also the only path that it can go down to have to drop all 10 volts. So yeah, 10 volts. Okay, next up, we're going to go to green. IA, IB, and IT. Do we know any of these currents? Yes or no? The answer, no, that is correct. We don't know any of the information for current. We can't write down anything for current, so we're going to leave it. We're now going to look at resistance. We've got RA, we've got RB, we've got RT. Now, do we know any of these values? Do we know the total current, the total do we know the resistance through A? Do we know the resistance through B? Do we have any of this information? RA is 2, RB is 3. Yep, beautiful. 2 ohms, 3 ohms. We don't know RT. Okay, now that's all the information we can gather. Well, actually, there's a little bit of more information we can gather from our circuit. This is not necessarily always that useful, but I want to get you guys to start critically thinking. We've got a 2 ohm resistor and a 3 ohm resistor. And our electrons can choose whether they want to go to through the top one or the bottom one. Can I ask you guys, and this is going to be a bit of a thinking question, which of these 2 resistors is the path of least resistance? Which of these 2 circuits is easier for our electrons to go down? A or B? Okay, well, one person saying A. So anyone else? I want to get maybe 3 answers. Which path is the path of least resistance? A or B? There's 2 answers for A, 3 answers for A. Any more people that want to take a guess? Everest, I think that might be the first time you've given an answer. I'm not sure. Yeah. So if this path is the path of least resistance, and so therefore, you would actually expect the current through, I'm actually going to write this down. This is just a little thing here. You would expect the current through A to be greater than the current through B. Now you might think, okay, do I need to write that down? No, you don't need to write that down if you're doing a test or even if you're doing a worksheet. What I'm telling you guys this for is so that you guys have something you can check. At the end of this question, if this is not true, then something wrong has happened. But just keep that in mind. Keep that in mind as we go. So IA should be bigger than IB because it's the path of least resistance. More current is going to want to go down the path of least resistance. And I always love that as a teacher, and as a math teacher, it's always really important for me. Now, let's go back to our good old game of tic-tac-toe. The first one that I think we could do would be good. I'm going to save RT to the end because I hate doing RT. The first one I think would be good to do is this line here. Let's calculate IA. I'm going to do that over here on the right. IA. Well, to do that, I'm going to go VA equals IA times RA. Therefore, IA equals VA divided by RA. VA is 10 volts. RA is 2 ohms. So that means IA is going to be 5 amps. So that gives me a voltage, that gives me a current of 5 amps through IA. 5 amps. Now with IB, it's actually the same formula. VB equals IB times RB. IB equals VB divided by RB equals 10 divided by 3. 10 divided by 3 is going to be 3.33 recurring. So therefore, IB is 3.33 amps. Hey, what do you know? I'm actually just going to write 3.3 because I've run out of space here. What do you know? IA is bigger than IB. Tip, we didn't make a mistake. Again, it's always a good place to check if you're working out. So, the next thing is to calculate I total. Can anyone tell me straight away what they think I total is going to be? What do you guys reckon I total is going to be? And if you have no idea, I've drawn this to kind of help you guys out. Not quite 8.5, but you're on the right track. $8.3. It is 8.3. I total in this case is going to be IA plus IB. That means it's going to be 5 plus 1.3, which is going to be 8.3 amps. Now, you could say 8.33 amps if you want to be specific. It doesn't matter too much. I'm not going to be too much of a Nazi at decimal places. But yeah, in general, as long as you get a good answer around that, you should be happy. Now, the last step, how does 5 plus 1.3 equal 8? That's why it's not 5 plus 1.3, it's 5 plus 3.3. So you see, I've got 3.3. And the reason I got 3.3 is I went 10 divided by 3, which is 3.3. Now, the last step is the total resistance. The total resistance, I'm going to do the easy one. The total resistance is, I'm going to work that out using this. I'm going to say VT equals IT times RT. I'm going to say that VT divided by IT equals RT. VT is going to be 10 volts divided by 8.3 equals 10 divided by 8.3 is 1.2. 1.2 ohms. Now, if you wanted to do it the other way, by all means, I'm not going to stop you guys from doing it the other way. But I find this other way just a little bit difficult, especially when you've got different denominators. Because what you've got to do is you've got to change it to be the same denominator, which is going to be, a little bit challenging. And if you're not good at dealing with fractions, then this is going to be a pain in the butt. Yeah, that's just enough. Yeah. I actually did, but you might have to do that in some questions. But just be aware that there's usually two ways to solve a particular problem. And if you could actually do this completely backwards, by the way. You could find out RT, then use RT to find out IT, and then use IT to find out what VB is, if you know what VA is, or something like that. It doesn't matter which way you go through this tic-tac-toe, as long as you fill everything in. And they've got one last example. Yeah?
On the bottom right, is a 5 plus.
Oh, is that
1.0.
where people...
And in the middle, where the dividing part?
I believe in the middle of the dividing parts. I don't know, hold on. Firstly, this is where I went wrong. That should be 3.3 because we're taking that down here. That's why. The middle of the dividing parts. What middle of the dividing parts?
The arrows with 5, 8 on the top.
Oh, here.
1.
Okay, fair enough. Okay, so sorry, but my bad. That was my mistake. But yeah, I haven't done a very good job of teaching this today because I keep making little mistakes. But hopefully, but that's why I'm glad that I've got you guys here to help me correct it. And of course, you know, we can always double check these kinds of things. Let's keep going with the last of our examples. So this is the last of the examples here. This is a bit of a backwards one. So I'm going to give you guys about a minute to copy this down, and then we're going to tackle it together. All right, so we have ourselves another parallel circuit, except we don't know what one of the resistances is. And what we do know is we know what the total current is. So this is going to be a bit interesting. You should know, guys, I could give you guys random bits of information. I could instead give you guys, maybe make 2 unknown resistances, but give you 1 current through 1 section, and so on and so forth. Then again, with this type of question, there are lots of different ways to solve it. I'm going to go through the same methodology that I've been doing for all of these questions. Okay, we're going to write down. We're going to name these A, B. It's a basic parallel circuit, okay? There's 2 paths. Now what we're going to do is we're going to call this VA, VB, VT. Now we happen to know VT is 8 volts, but because this is a parallel circuit, this and this have to also be 8 volts. That's what makes parallel circuits so easy. I actually usually give 3 marks for one of these types of questions, so it's actually quite easy to get 1 mark by just copying the answer down. Now, if you didn't know what this was, once you get one of these resistor voltages, you get all of them. So that's one of the things that I could give you a completely different question where I don't tell you what the voltage of the battery is, but you can work it out. Now, in this case, IT, IA, IB, IT. But once we do know something about the current, we know that's 10 amps. We don't know what IB is or RB is, so we can't do much there. As for RA, we don't know what RA, we know what RA is, it says there it's 2. We know what RB is, RB it says here is X, but we're not going to write that down. And RT we don't know. So yeah, it leaves us with a lot of blank spots here. But even though there's a lot of blank spots, there is still one thing we can solve. And that is this guy right here. We can do a tic-tac-toe straight across the top. How does that work? Well, we can work out what the current through A is. We can work out what this current is. Because we know for this circuit, it's losing 8 volts. And we know that it's got 2 ohms, so therefore we can calculate the current. Let's work that out. VA equals IA times RA. In this case, IA equals VA divided by RA equals 8 divided by 2, which happens to be 4 amps. Now, if I know this is 4 amps here, and I know this is 10 amps coming out, what's the next thing I would calculate? Using your tic-tac-toe methods, what's the only other thing that I can figure out now? There's only one thing you can figure out, actually. Actually, no, sorry, I'm lying. There are 2 things we can figure out. I'll let you guys choose, and I'll do whichever one comes up in chat first. What's the next thing we can work out, or you guys want to work out? IB, perfect. That's what I would suggest. You could also figure out RT, but I would suggest IB. Now, IB, we can't figure out IB using V equals IR. The only way to do it is to do a line up and down. That's because if I know this is 4 amps from the top and some amount of current from the bottom, that has to equal 10 amps. So IT is going to be IA plus IB. Now IT is 10. IA is 4. So that means that IB must be what? What is IB? What is the current through resistor B? Can someone tell me? What is the current through B? 6. Thank you. Correct. 6 amps. 4 plus 6 makes 10. So that's why this is 6 amps. Now that we have this as being 6 amps, we have enough information to work out what RB is. We can also use some maths here. We know that 6 is greater than 4, so we know that therefore the resistor B must be the path of least resistance. RB must be less than 2. Let's calculate RB. We're doing this tic-tac-toe for those of you that want to know. RB, to do RB, we need to use this formula here. V equals IR, VB equals IB times RB. So RB is going to be VB divided by IB. Is going to be 8 volts divided by 6. 8 divided by 6 is going to be what? 1.25? No, 1.33. Oopsies. Thank God I used the calculator. 1.33 ohms. Now for RT, now I'm going to calculate RT by doing this tic-tac-toe. But remember, you could also go down instead. But I'm not even going to try that with 1.33 because that's technically going to be 4 over 3. So we're going to have 4 over 3 plus a half. Ugh. No, can't be bothered. I'm going to do the easy method instead. VT equals IT times RT. VT divided by IT equals RT equals 8 divided by 10, which is 0.8 ohms. That's it. That's how we can do any unknown thing. It's the same process. You're either doing lines across or lines vertical. And the trick with doing lines across or doing lines vertical is to understand whenever you do a line across, like lines that go across, all you need to use is V equals IR. It might involve you rearranging it, but that's what you do for lines that go across. For lines that go up and down, you need to know that VA equals VB and so on. You need to know how the currents add and the resistances add, but they add in a weird way, 1 and RT. So I usually explore it like this. Now I'd strongly suggest that if you're a bit confused about how I've done this for parallel circuits, or you're a bit confused about series circuits, go back and watch the YouTube video when they do go up. The YouTube video for the last lesson is going to go up this afternoon. I just didn't put it up because I went to bed, but I will put that up this afternoon so you can access it there. The last little bit that I'm going to explore, I've got about 15 minutes. So the last little bit that I wanted to talk about, I wanted to talk about this. No pencil here. Okay, but what I wanted to talk about here is that you can get combinations of 2 of them. So you can get the situation where you've got more than one resistor on a thing. So, and I'm not going to solve this because I don't want to scare the crap out of you guys, and I don't want you guys to start thinking that, you know, I don't want you guys to start panicking and being like, oh my God, do I have to solve these? Are questions like this going to be on the test? No, they're not going to be on the test. I'm not even sure if I gave these types of questions to, actually I think I did give these types of questions to my year 11 students, but yeah, you do not have to worry about this. Saying that though, you guys actually have all the information you need to be able to solve a question like this. You just need to treat this section here, this series section, as one big resistor. So instead we would end up with RB. You would end up with some complicated thing where you have RA equals 2 ohms, you'd have RB equals RB1 plus RB2 equals 3 plus 1 equals 4 ohms. And then you could solve the rest of this. So then you would have IB and IA and so on. And then you have VB1 and VB2 or whatever. And you could solve this using the same sort of methods that we did before. You could just calculate it. You could instead calculate just VB. And then once you work out what VB is, you work out what each individual voltage is for each of those. Because you'd expect more voltage, you're going to get drops here than there. But it's not impossible. So yeah, ladies and gents, that's all that I had to talk to you guys about today. What I'm going to show you guys for the end of the lesson and stuff that I would like you guys, this is, by the way, a bit of an in-joke. If you sort of get the whole idea of the path of least resistance and how electrons really want to avoid paths of high resistance, then you should get an idea of why why maybe the current's not happening through this circuit here. Mind you, this is a super nerdy joke, so I don't actually fully expect you guys to get